Okay, I'm just going to run through this Nite Ize Bike Lite with its associated CAD model and bill of materials to show kind of the progress that I'm making building this out so that I can go get manufacturing quotes, kind of cost representative quotes so that I can start to understand where opportunities exist. I have my ideas, but I just really want to be able to have quantitative data for the original design and how that relates to the new design. So in the model, we have a number of sub-assemblies. We have the top level bike light assembled, that's in the package. We have the upper housing, which is its own assembly. So that's here. That includes the lens, the button, which we've learned is an overmold, and then this entire assembly has another level with a part number that adds the pad printing or the stamping. The internal chassis assembly, which has some complexity here. It is the spring tabs for the battery terminals, the PCBs, the aligner piece, the ribbon that goes in and around the battery, and what we're calling the ribbon retainer clip, which is this little guy in here. And then it also has a couple of wires, 22 gauge wires that come down and solder. And I haven't modeled them perfectly, but these tabs actually fold over the top and they solder onto those wires there. So that's the chassis assembly. It's really just the lower enclosure, which is a molded part, and then two overmolds. So we have what I'm calling, so that's why they have the same part number. They're actually going to be part of the same tool. So we have one tool that makes the lower overmold, and then one tool that adds this rubber base and this rubber main seal. So that's one operation, two overmolds. So that would be in one drawing under the 100-160. And that is the upper level assembly. If I look at the exploded view, you can start to see what is all going on in here. Okay, so fix the exploded view. So now what I have is these are all the parts that make up the assembly. Every one of these parts is going to need a drawing, a material call out, a surface finish definition, a material, I mentioned material spec, and whether it's a purchase part or a manufactured part, a manufacturing operation defined, and they'll need to all be reviewed for DFM. And I just want to walk you through kind of how I think about the bill of materials and what that looks like. Top level, we have a BOM item number 1, which is really just the bike light, and it's the packaged bike light. I'm calling that an assembly. It's made up of various materials and it has a manufacturer part number. In this case, the manufacturer part number might be the SKU or the SKU number, but it might be a different part number as well. If it's a purchase part, we're going to buy it from a vendor. So vendor part number would go here and who we're going to buy it from. If we expand this, we have the bike light assembled, which is the one we just reviewed in Onshape. That was the 100-151. As an assembly. And the packaging itself, if we expand that out, is actually 3 separate components. It has a cardstock that's printed and folded. It has a blister for the front of the package and a blister for the rear of the package. There's some labor associated with this packaging as well. Inside the packaging is a large O-ring, some batteries, instructions for use, and a printed card. And the quantities are all listed here, and how we're going to manufacture each one of those parts is also listed here. So each one of these parts is going to get its own manufacturing part number, and how we're going to plan to make that manufacturing method here. Now note that this bill of materials is not connected directly to my Onshape model. Right now I'm running with 2 separate data sources. I have a bill of materials, which is actually more exhaustive than my CAD model. And then my CAD model eventually will catch up, and then one of these will be the main manufacturing documentation. But for now, I'm running 2 separate BOMs, and you'll find out why here in a second. So Inside Bike Lite assembled, I have the three sub-assemblies that I reviewed before: the upper enclosure, the lower enclosure, the chassis assembly, and then some O-rings, which are not in the model right now. If I drop down the chassis assembly, you'll see the chassis assembly includes some injection molded parts, some purchased screws, some printed circuit boards, some purchased battery terminals, wire, some rivets, some solder, some ribbon and retainer clamps. Some of this stuff is in the model enough so that we have a placeholder. Some of it is in the model with accurate geometry. But for what I'm doing right now, I'm only putting representative geometry into the CAD model so that I can start to understand the manufacturing cost estimates. In the lower enclosure overmold, there is the lower enclosure and then the lower overmold. I mentioned those are two separate parts. So I have this 100-160 is the lower overmold. That's made of TPE, and the enclosure lower is the ABS part, 100-159. Those are two separate parts. They each have their own independent materials. They will each have their own inspection criteria. They will each have their own quality inspections. And as they come together to become the lower enclosure overmold, number 15 here, this 100-158 is now a part that can't be separated back to its disparate entities, and it has its own inspection dimensions. It has its own material callouts. It has its own inventory requirements and things. So being able to identify every level of this bill of materials so that we can correctly source the entire bill of materials is very important. For example, I have the upper enclosure, and I have it called out as the upper enclosure printed. So the way that I'm imagining this gets built is you have the upper enclosure and it gets stamped as its final operation. We could argue that it gets stamped at a different state in the process, but this is the assumption I'm making today. So I'm saying that the stamped enclosure is actually, the stamped enclosure is actually the upper enclosure assembled that then gets pad printed. And that upper enclosure assembled includes the lens, some glue, and the upper enclosure. So we're basically taking here's the upper enclosure assembly. We're taking this enclosure with the button on it. That's one part number. It's the 100-155. We're adding the lens to it, and then we're adding some adhesive, which is not in my CAD model. So we have the upper enclosure overmolded, with the button. We have some glue, and then we have a lens that makes a new part number called 100-153. That's a bonding operation. It requires various materials. So I have my injection molded part, my purchased, and my overmolded part. Those components, those three parts, all come together to make the upper enclosure assembled. So being able to separate this all out so you can identify what are the manufacturing processes, what are the materials used, how can we identify where our cost savings opportunities are. Lastly, the upper enclosure overmolded. I've alluded to this, but there's the upper enclosure and then there's a button overmold. That's a TPE. This is an ABS. That comes together to make this 100-155, which is its own part that can sit in inventory on a shelf. It can't be separated back to those two parts anymore. So this would have its own inspection. You might choose to work with a vendor who doesn't need a fully detailed bill of materials like this, and they might be able to work with a bill of materials that looks more like this. And you might be able to find a vendor that says, oh yeah, that upper enclosure printed and bonded, you can just send me the multi-body part. We'll piece it out on our end. The risk to running that with that method is that you can run into issues where you no longer understand or control any of the processes between your part and your finished assembly. And what we'd like to do is have a document to inspect at each step so that the whole thing gets assembled appropriately and then put together at the top level correctly. And at each step, we can define what we're inspecting for quality to make sure seals are functional, to make sure that surface finishes are appropriate. And we don't want to wait until the entire unit is is built and assembled to check those things. We want to check them as they're coming in and check them against their manufacturing documentation. So eventually each one of these will get its own drawing, and we will have a full documentation package that looks like this for this Bike Lite assembly. So that's how I think about the bill of materials. If I pop into the bill of materials here in Onshape, you will see that I can view it in a couple of different ways. Right now I have it as a structured view, but if I view the flat view, each item in the bill of materials from the Excel spreadsheet has been copied over here so that my models are associated. They're loosely associated. If I change the spreadsheet, it doesn't change it in Onshape right now. That's why I say I'm running with two separate data sources. But for what I'm doing for pricing and quoting, this is very quick and easy. I can copy this table out and paste it into Excel, make a bunch of edits, and then bring it back in here and paste it back into Onshape, and all my part numbers will renumber themselves and update accordingly. So this is a really quick way to keep my bill of materials aligned. And as I start to get into drawings and quoting, this is really helpful information. So that's, again, just a brief overview on a fairly complex little electronic device with lots of manufacturing complexity, significantly more than I had intended or imagined when I start to dig into this. We have a lens, which is a and B moldable part, so straight pull, no side actions. We have the Nite Ize upper housing, which is overmolded, and you'll see we have one undercut here underneath these, I'm sorry, two undercuts here underneath these hooks that need to be pulled by the molder. These hooks are okay. This entire face here, all the way around the button, is a big undercut, so they have to pull that face. It's actually a through hole with a bunch of little holes that poke through, so that's not only an undercut, but it's also an overmolded undercut. So a very challenging little undercut and overmold to do in a manufacturing environment. It'd be interesting to see how this gets quoted. And then there's also several other undercuts that will have to be pulled with a side action or a slide on the inside of the housing. There's two here, and then one on each end for retaining the chassis component. We've talked about the screws and the chassis assembly being an opportunity for cost out redesign. These battery terminals are off the shelf. I don't anticipate they will be significant in money savings, but the way that they are installed, both this aligner piece with these 4 screws up here, which I've argued is a useless part. It doesn't do anything other than align the printed circuit board, which we could do with ribs on the back of this piece. I think we can get rid of this part. I think we can get rid of these screws. But these battery terminals and their rivets are all placed into this chassis part. And the more I started digging into the chassis part, it itself is a very complicated little part. It has side actions coming out both ends, holes for the rivets to pass through. It has a side action out the side for the ribbon to pass through, unnecessary feature. It has side actions inside of both faces for the battery terminals to install into. And that is about it. These hooks on each end are moldable from the top and bottom, so those don't need to be side actions. So it's its own little complicated little piece. I think there are a few opportunities there to decrease cycle time, decrease the amount of resin, simplify the inside, how these battery terminals get installed. Batteries, I don't think we're going to cost optimize them at all. They're AAAs. We're going to stick 3 of them in there. Our pricing on those will be what it's going to be. The lower enclosure overmold, there's a few opportunities here to reduce cost if we keep this design. Here, 4 side actions. That limits our cavitation on the mold and limits the number of parts we can fit into the tool. It also is a slider right on top of an overmold, which is kind of an interesting design choice. And then there's an additional side action right here in the side that's like a little coin pick-out feature. So not terribly complicated part, but complicated enough that I think we can reconsider how this part comes together. potentially even make the whole bottom piece out of TPE, eliminate the rigid plastic entirely. Might be one way we could do it. So next video, I'm going to dive into manufacturing sourcing and how I prepare these files and how I send those out to manufacturers and work through the pricing of this unit. If you like this video, hit subscribe. It helps. I can continue to make more content like this. Thanks.